Welcome to Drawing in a Swift Playground. We're actively writing chapters for the Game Programming of Swift course, and we're going to release them as soon as they're ready. But I just wanted to give you a little tutorial on how you can make some basic drawings in Swift using the new Playgrounds feature. I've made a custom playground for you with all of the material in this video. You can find the URL to download it in the description. I want to point out before we get started that this video isn't intended to be a whole course, it's just a little taste. If you're new to programming and you feel a little lost, don't worry. The full course will go into a lot more detail and help build the mental scaffolding necessary to write these examples. The first thing that we want to do is create our own playground. At the time of writing this video, you're going to need the new Xcode 6 beta in order to run these examples. But by the end of the year, anyone should be able to download it. You've probably seen around the internet that Apple actually provides their own guided tour playground of the Swift programming language. I put the link to their guided tour in the description, but you should definitely download it and try playing around. This will give you a really basic introduction to the Swift programming language, and it's a lot of fun to play with. Instead, what we're going to do in this video is we're going to create our own playground, and we're going to do some basic drawing operations. So to create your own playground, you're actually going to have to close all of your Xcode windows, and you'll probably need to quit Xcode, and then launch Xcode again. This should give you this project window in Xcode. And we want to choose Get Started with a Playground. I'm just going to save it to my desktop. The first thing that we need to do is import a couple of things. When we use the instruction import, we're telling the playground that we want to use some code that other people have written. So here we're going to import Cocoa, and then we also want to import a module called XC Playground. The first thing that we're going to do is download a picture from the internet, and we're going to show it. To program this, you can think of it kind of like creating a digital picture frame. So before we can show a picture in a digital picture frame, we actually need the frame first. To build a picture frame, we have to specify how big it's going to be. So let's tell the program that we want a rectangle that is 300 pixels high and 300 pixels wide. To do that, we're going to create a new variable. We'll say var frame rect. We're going to define a rectangle which defines the size of the picture frame that we want to draw. So we'll say frame rect equals ns rect, and we want to say that it's at the x coordinate of 0, the y coordinate of 0, with a width of 300 and a height of 300. All of our drawing happens within an xy coordinate grid. So here we're saying that we want our rectangle to start at x0, y0, the origin point, and we want it to have a width of 300 and a height of 300. One of the cool things about Playground is it has really neat preview features. To make sure that your setup looks like mine, go up to View, Assistant Editor, and pick Assistant Editors on the right. Then go to View, Assistant Editor, Show Assistant Editor. And here you can see on the right-hand side, we've got an empty view here. We can use this area to preview some of the changes that we're making. So here, click on our frame rect line and hover over here. You'll see there's two things. Click on the eyeball, and you can see we've defined a rectangle with xy at 0, 0, and it's 300 high and 300 wide. Now, to continue with the picture frame analogy, we can put a lot of things in a picture frame, right? You can leave your picture frame empty, you can put in a paper photo, or you can put in a digital screen which would show photos if you had one. So in our picture frame, we're going to use what's called an image view. You can think of an image view like the screen in our digital picture frame. This image view, the screen, it just displays one image. So we need to tell the program what size to make our image view, and to do that, we're going to use the frame rectangle that we just created. To create an image view, we'll say var view equals ns image view, and we'll pass the frame of the frame rectangle that we just defined. Now we have a frame and a screen, but we don't have anything to actually show yet. We need a picture to show in our picture frame. And I happen to have one of a friend's dog named Lady. The first thing that we need to do is tell the program that we're going to give it a URL. We do that like this. var dog picture URL equals ns URL. You might be used to just pasting a URL directly in your browser, but in Swift, we want to tell the program that we want a URL object. And so to create a URL object, we use this NSURL function. So we say dog picture URL is a new URL, and we use this string to specify where this URL points. Now we need to actually download the URL and put it in an image. We can create an image using the function NSImage. So let's type var dog picture equals NSImage contents of URL dog picture URL. So now we can actually view this URL by hitting this plus symbol right here. Hey, there she is. Now we need to tell our view that we want to show the dog picture. We do that by setting a property on the view. This is an image view, and so you need to tell the view what image to use. In Swift, almost every object has properties. You can think of properties as something that an object is or something that an object has. For instance, a piece of fruit has a color and a shape. So an orange is orange colored and round. An apple might be red and apple shaped. One of the properties of our view is that it has an image. We tell our view which image we want it to display, just like you might tell like a real digital photo frame. To tell our view to display the dog picture image, we say we assign the dog picture variable to the image property of the view. So we say view.image. This is how we access a property by using dot. View.image equals dog picture. Let's close this preview right here. And the last thing that we want to do is to tell Playgrounds to show our picture frame. To do that, we use xcp show view. And we will call this work, and we'll pass our view. There we go. This xcp show view function, that stands for Xcode Playground show view. So you'll notice we did two different things here. When we click on the plus sign right here, what we're doing is we're asking Playgrounds to show a preview of this NSImage. This is showing the image directly. But when we did xcp show view, what we're doing is we've created a view which is like the screen for our digital picture frame. And then we've assigned that image to the screen, and then we're asking Playgrounds to show that view. It's a little bit different. Viewing the dog picture is showing the image directly, whereas this, we're actually looking at the view. This is important because we might want to have several things in a view, and you're going to use views all the time when you're programming in Swift. All right, we know how to load an image and display it in our view, but how do we draw our own images? The first thing that we have to do is to tell our program what size we want to make our image. So let's specify a size. We'll say var size equals ns make size 300 300. We can preview that size. And then we need to create a new image. We'll say var image equals NSImage using the size of the size we just defined. This will create a blank image. Now we have a blank image. We have to tell the program that we want to draw in our new image. To do that, we have to lock the image. By locking the image, we're saying that when we give drawing commands, which we're coming up next, then we want those drawing commands to be sent to that image. So the first thing that we have to do is image.lockFocus. By calling this lockFocus command, we're telling Playgrounds that we want to draw on this image. So on our image, let's draw a rectangle. To draw a rectangle, we're going to use the command nsRectFill. When you call nsRectFill, it takes a rectangle as an argument, and it will fill it with that color. So we have to make a rectangle, so we'll say nsMakeRect. And nsMakeRect takes 4 arguments: the x-coordinate where the rectangle should be placed, the y-coordinate where the rectangle should be placed, the width, and the height. Now, whenever we lock something, just in general in programming, we almost always need to unlock it. So here we'll type image.unlockFocus. And just how lockFocus says we want to draw on an image, unlockFocus basically says we're done drawing on this particular image. To get a preview of this image, let's click this plus button right here. And there you go. You can see we've got a little square at 0, 0 that is 10 pixels wide and 10 pixels high. So try playing with these values. What happens if you put in 50 here? Or what happens if you put in 100 here? We can move them around. And by playing with these values, we can get a feel for the coordinate system, get a feel for how the different rectangles that we can make. And by playing around, you can get a better sense about what's going on. So we don't have to limit ourselves to just rectangles. We can also draw lines. When we go to draw lines in Swift, we have to break it down into little steps. Here we don't have a simple draw line function, though we could make one. Instead, we start with an object called a path. So it's worth thinking about, what is a line anyway? What do we mean when we say line? Well, a line, when we're saying line here, we mean a stroke of color between 2 points. So to draw a line, we need to pick a starting point, which is an xy coordinate. We need to pick an ending point, which is an xy coordinate. And we want to paint a stroke of color between the two. If you've ever used a vector drawing tool like Adobe Illustrator, then this should be really familiar to you. You can have a path in Illustrator that's invisible, right? You can also style the same path with lots of different strokes or colors. You can use dashes or brushes without changing the underlying geometry. And so what we're doing here is essentially the same thing. We want to draw into a new image. So let's say var image2 equals nsimage of a size, reusing the same size that we had before. And we want to draw on that image, so we need to lock it. So to draw a line, we need to do 4 things. First, we're going to create a path object. And to do that, we're going to use the function nsBezierPath. So we do var path equals nsBezierPath. We're going to be drawing a straight line here, but you can obviously use a Bezier path to draw beautiful curved lines. We're not going to worry about that right now. The second thing that we need to do is move our path to the starting point. So we'll say path.moveToPoint, and we'll pass an ns point of the x-coordinate 0 and the y-coordinate 0. Next, we want to draw a line from our starting point to our ending point. Actually, we're not going to draw the line just yet, but in fact, we're actually just going to add another point to the path. So we'll say path.line2point, and we need to pass a new point, x 100, y 100. Now, those two commands, they don't actually draw the line. We have to call a stroke on the path to actually draw the pixels. So we'll type path.stroke. And we're done drawing on this image, so we'll say image2.unlockFocus. So now on this image2 unlock focus line, let's hover over the plus sign and take a look. All right, we did it. We drew a line. Just like before, try playing with these values again. We can make the x-coordinate be at 200. We can move this y down to 50. And by playing with these points, we're drawing a line between two different areas. Let's look at one more example. We can also draw more complicated compositions by using loops. Let's start by creating a new image. And in this example, we're going to create a variable called shift and set it to 0. Then to make this pattern, we're going to use a while loop. In fact, we're going to say while shift is less than or equal to 200, then we want to do whatever is here. And every time we go through the loop, let's increment shift. We'll say shift equals shift plus 14. So what's going to happen here is that shift is going to start at 0, and as long as shift is less than 200, this loop will run. And here at the end of the block, we're saying shift equals shift plus 14. And you can see that Playgrounds right here is telling us that this line is happening 15 times. Let's click on this plus symbol and take a look. Playgrounds gives us this sweet chart that shows us the value of shift as this program runs. You can try changing this to 10, and then you can see this runs 21 times. Or you can change it to 20, and you can see that it runs 11 times. And each time we change this value, we get a preview right here that shows us what the value of shift is. So let's set it back to about 14. That's a good number. Within this loop, let's lock our image. And then we want to draw a path, just like before. So we'll say var path2 equals ns Bezier path. And we want to move our path to the starting point. In this line, you can see that we're setting y to the number 300, but we're setting the x-coordinate to shift. Well, shift changes every time we go through this loop, so this is going to give us a more dynamic image. Now that we have our path at the starting point, we need to also draw the line to the ending point. So we'll say path dot line to point, and this one will say go to x0 y shift. Then, in order to see our path, we need to say path.stroke. I actually made a mistake here. Here I defined path2, but here I called path, which is actually referencing this first path up here. So let's change that. Let's change this to path2, path2, path2. Don't want to forget that. Now, at the end of this block, we'll say image3 unlock focus. Got another typo here. Xcode is helping me by showing me that this has a bug. That's why it's underlined red. And you can click on this and see NSImage does not have a member named lockFocus. I actually forgot to uppercase right here. There we go. Now you can see that this ran 15 times. And click on the circle button right here. And take a look. We can scroll down here and we can see each iteration of what this image looks like. Now, this preview is showing each individual step. It would be nice if we could actually see the final image too. To do that, we use the playground. We ask playground to show us our view just like we did earlier. So we say var view3 is a new NS image view. And we'll say the frame using our frame rect from earlier. And the view3 image is going to be image 3. And we'll say Xcode playground show view, and we'll call this a parabola, and the view will be view 3. And let's look over here. There we go, we can see our final image. To get a better idea of what's happening here in this loop, the best thing that you can do is play with these values. What happens if you switch this to 200? Or 100? That's really interesting. It kind of changes the shape. Or what happens now to our image when we change this to 20? Or 5? Pretty interesting. So I'd encourage you to play around with these values and try to get a sense for what's going on. If you click this button right here next to unlock focus, you can actually see each step as the picture is drawn, right? So this is our very first line, this is the second line, the third line, the fourth line, and so on. And so by using playgrounds, this is a really good way that you can get an intuition about an algorithm. You can get an intuition about the procedure and the steps that it's going through in a way that hasn't been very easy until now. Play with this example and let me know how it goes. If you have any questions about this, you can send me an email to us@fullstack.io. So there you go. This is a quick taste of drawing with Swift and Playgrounds. If you want to try other types of shapes, adding color, etc., we'll definitely be adding a few lessons for that. For now, you should try looking at Apple's introduction documentation to Cocoa Drawing. I've put the link for that in the description. So I realize that for some of you, I probably went a little fast, and we're making several videos that will help get you up to speed. And some of you are chomping at the bit for more advanced material, and that's coming too. We're working on videos for building your own games in SpriteKit. You'll be able to run these games on your computer or on your phone, and we'll teach you how to go from an empty folder all the way to the App Store. We'll teach you everything you need to know to build a whole app without skipping any steps. So if you have any questions, send me an email at us@fullstack.io. That's all the time that we have for today, so I'll see you next time.